Okay, let's do this one. Obviously, a little bit easier because we don't have to do the total capacitance. That's easy. It's given to us. It's just a single. Bear in mind this is 0.6 microfarads, so we got to make sure we use the right amount of zeros in our formula. Just R1. Notice frequency has risen dramatically to some others, so you might see some interesting effects there. We will see. So to get total capacitive reactance, we're going to apply the formula 1 over 2 pi Fc, just like we've been doing all this time. So nothing new there. So to get this x of c, 1 over 2 pi Fc equals. And I'm not going to write the values here. I think we've gotten far enough along that you understand that, but I'll talk about them when I enter them in. So obviously 2 pi is 2 times 3.14, which is 6.28, times the frequency this time. Now notice here, I'm trying to move my calculator over, our frequency is 10 kilohertz, so times 10,000 equals, and then our capacitance is 0.6 microfarads, so that's 0.00345, and we've got to add one more because it's 0.66 equals, and then we take the inverse of that. The inverse of that, basically dividing this value into 1. If you notice, it's taking x, which is this value, and dividing it into 1. So that gives us 26.54 if we round. So I'm going to place that there. So that is 26.54 ohms. Well, our total is pretty easy. It is, I'm going to keep moving my calculator over our problem, so let's get it down here. So it is 26.5. Kind of interesting, huh? So that was probably quite on purpose, I'm sure. So 26.5 ohms. So there we have that. So the next thing is we've got to get total impedance. And remember, that is this formula right here, which is ZT, or total impedance, is equal to R squared plus X of C squared. So R squared plus X of C squared. So basically we're squaring this, we're squaring that, and then we're getting the square root of that. So we'll bring back our trusty calculator. I'm going to go ahead and square that because that is our X of C squared plus 26.5. This is our R squared, which is 26.5 squared, equals, then we're going to get the square root of that. So 37.856 is our, let's write that down, our total impedance. So, which equals, well, we changed to black somehow. Best press the button, that's fine. I forgot what the number was on the calculator, so we'll go back. 37.86 if we round. 37.86 ohms. 37.86 ohms. So that's Z total. Now it gets much easier now that we've done all this, now that we've got our Z total over here. All we have to do is divide to get total current. I is equal to E, which is 10, over 37.86 equals. So we'll break out the calculator once again. We'll say 10 divided by 37.86 equals, and that is 264 milliamps or 0.264 amps. I'll write it in base units. So 0.264 amps right here. So we've got I, and now we can begin to calculate these voltage drops here. And remember that formula is pretty much the same. We multiply I times R. Well, our I, I'm trying to get it where you can see everything here, but we can do that. Our I is 26.264 amps, I should say, 4. And if we multiply it by R1, we get basically 7 volts. I think 6.996 is enough. We can round that to 7, and NIDA will be happy. And we'll do the same thing for here. I hit the squared when I did that, so I apologize why it changed. And then we have to take the X of C, which is 26.54 times 0.264 equals, and again, 7 volts. That shouldn't have surprised us because our X of C and our RT are the same, so if we apply the same formula to both, we're going to get the same results. Remember, we can check this because EA is equal to, let me write this formula down just to get a reminder, good way to gut check. So let's come here, and E applied is equal to the square of ER squared plus the square of E X of C squared. So basically we're squaring the two sevens, adding them together and getting the square root. So let's break out the calculator once again. I'll move it where you guys can see it. So we're going to say 7 squared plus 7 squared, whoops, not 7, 2, excuse me, we'll start over. 7 squared plus 7 squared equals, and get the square root of that. 9.899, again a little rounding, pretty close though to 10 volts AC. So I think we got the right answer there. We'll hit enter and see, and sure enough it says we are correct. So kind of finishing this up, remember when solving for values in an RC series circuit, R and XC are affect current 90 degrees out of phase and cannot be added directly. ER and EC are not in phase and cannot be added directly. IR and IC have the same phase. Current is the same at every point. Now we're going to talk about power. The last circuit value of power in AC circuits for reactance. There are 3 types of power: real, reactive, and apparent. And real, we apply that formula there. Real is equal to PR being real is equal to ER times IR. For reactive, PC is equal to EC times IC. And last but not least, apparent, PA is equal to EA times IT. So, all Ohm's law formulas, just different values of those, and it's going to talk a little bit about that. So really, that's pretty much it. This should give you some insight to some RC circuits. I'm not going to work any practice problems for you. I want you to begin to work some of those. If you hit a brick wall, please get with an instructor. Rewatch the video. That should help you. But all of these practice problems should be fairly easy to you if you got through this lesson and pretty much understand what you've seen up to this point. So again, anytime we can help you, if you have a particular problem, and even if it's the weekend, don't mind trying to answer an email when I have some available time. So feel free to email me at lradney@oftc.edu. Thank you very much.